All right, so we are looking at variable charge transition metals. So we don't know their charge. There's not a nice, neat little pattern to them. You should know where your transition metals are on your periodic table. So we're going to start with iron 2 oxide. And the first thing that you should notice is this Roman numeral in here. Well, that Roman numeral is going to accompany transition metals, so gold, iron, silver, zinc, those metals that are in the middle. Remember, we said they have a variable charge, so we can't necessarily predict it by a pattern like we can some of those fixed charges on the periodic table, like sodium is in column 1, so it's got a charge of positive 1. These metals we can't predict, so we use these Roman numerals right here to tell us what the charge is. So it's pretty easy when you're trying to go from the name to the formula. So I have iron. I look it up on my periodic table and I know iron is Fe. I know I have a charge of 2. Oxygen, I know is O. Oxygen I can look up on the periodic table. Its charge is also 2. And now we just cross down. So how many irons do I have? Well, I have 2 of them. How many oxygens do I have? Well, I cross that down. I know I have 2 of them. And I should be able to look at this and know, oh, we're going to simplify. So we are going to have Fe and O as our formula. Now, silver nitrate, or silver 2 nitrate. Okay, so silver is Ag. I know I have a charge of 2 with that one. Okay, and nitrate I know is NO3. And I looked that up on my polyatomic ion sheet. I see that has a charge of 1. So we're just going to go ahead and cross here. And I know I'm going to have 1 silver. And I'm going to have nitrate. And I'm going to have 2 of them. I'm going to want to keep that NO3 together, right? It's polyatomic. We never want to separate those. And so we put a 2 on the outside. So I have Ag parentheses NO3 parentheses 2. All right, gold. Okay, gold symbol I look up on my periodic table is Au. I look at my Roman numeral, I see gold has a charge of 3. Chloride. Okay, that's chlorine. Look it up on my periodic table. I see chlorine has a charge of 1. Now we cross. I have 1 gold and 3 chlorine, because that was my charge on gold. Gold 3 chloride. Okay, iron 1 hydroxide. Now, sometimes you won't even see the 1 there, so this may just be iron hydroxide. If we don't see a Roman numeral, then we're going to make the assumption that it is a 1. In this case, we actually see the 1 as well. So, iron, right, I know, again, symbol is Fe, charge of 1, hydroxide is polyatomic, so I look up on the polyatomic ion sheet, also has a charge of 1, crisscross, and I know I have 1 iron and 1 hydroxide, so we are left with FeOH, iron 1 hydroxide. All right, now, going from the formula to the name can be a little bit trickier, because now we have to kind of think in reverse. So, let's look at this. Zinc, I have 1 of them. How do I know I have 1 of them? Because that 1 came from the chlorine. That was a charge on the chlorine. So what was a charge on zinc? Well, if I cross that back up there, I know that, that 3 had to come from the zinc. So in this case, we have zinc. And remember our Roman numeral, because this is a transition metal, the Roman numeral tells us the charge. So zinc 3, and then we just name it like before, chloride. Okay? So this compound right here was zinc 3 chloride. Okay? So I'm going to erase this so I can give myself a little bit more room. Alright, next one. Fe. Well, we should know now, Fe means iron. So I know I'm going to have iron in there. Alright, now I know that I also get a Roman numeral with these, depending on what the charge is. Well, if I just look at this right now, I would guess that maybe the charge on iron is 1, right? Because we cross it down and we would have 1 phosphate, so we don't write the charge. Well, that may be the case, but if we look on our polyatomic ion sheet, we should see that phosphate actually has a charge of 3. So at some point in time, we would have needed to cross a 3 down to the iron, and yet we don't see a 3 next to it. So there's really only one scenario that would have to happen here. Iron would also have to have a charge of 3. Okay, because what would then happen is if we drop that 3 down to the iron and we crisscross that, we would have Fe3PO4 parentheses 3, and what would we need to do with those 3's? We would have to cross them out. And if we cross them out, then we would be left with FePO4. So what does the charge on the iron have to be in this case? Well, it's going to have to be a 3, so it cancels out with the phosphate. So we're going to end up having iron 3 phosphate for this compound right here. Okay, so iron 3 phosphate for FePO4. Remember, the 3's will have to cancel out. All right, and then last but not least, I'm going to erase that again so we have some room to write here. TiOH4. All right, Ti. Look for it on your periodic table. You should find that Ti is titanium. Okay, so I'm looking at titanium here. Now, let's cross our charges back. Well, hydroxide, I look at my periodic table and I see that hydroxide would have crossed down a 1. So this 4 would have been crossed back to the titanium. So in this case, you have titanium 4 hydroxide. And I'm not going to write that all the way out because I ran out of room, so we're just going to shorten it one up. So titanium 4 oxide, because the 4 comes back down. Now, these variable charges are some of the trickiest ones, so watch this a couple times if you need to. If you're still not getting it, then I probably need to see you in class.